Right, so you have all your laws here in case you ever see a question in algebra, which we're going to see that now. Right, you have all your laws here that you have to know. Right, you have your laws again. Right, if you have to prove something by algebra. Then you have all your statements here. What's the negation, conjunction, disjunction? Anybody remember the logic? Yeah, logic key that behaves like conjunction? No. Huh? Which one? And disjunction is what? Oh, nice. Then you have implies, right? Remember, implies is only false when what? When true implies false. Nice. Then you have contrapositive, converse, inverse. Right? When you hear that converse, what is do again? That should be Q there. Converse, you flip them around. Inverse, you what? You negate them. Contrapositive, you negate and you flip it around. All right. We have to remember all these little things. Equivalent, biconditional. When is a biconditional statement true? Biconditional true and what? Yes, so. When they both have the same truth values, right? True and true, false and false, right? Tautology means what?
Everything is the same.
And contradiction
Everything false.
and contingency, neither.
Yeah.
Right? That's the one that we use all the time. Right here we have truth tables. Well, you should remember how to fill this out, right? What will happen if you have two variables? How many options you have? 4. If you have 3 variables, how many options you have? Right. Well, if you have 4, well, I never have. If you have 4 variables, 16, right? 2 to the power of 4. Right here we have the real number system, binary operation. How do you show closure again?
Sign.
Huh?
Sign.
Nah. Closure. How do we show closure? Right? We have to simply show that if A and B belong to a particular set, then when it's B, right? If A and B belong to a particular set, then A star B, whatever function it is, should also belong to that set. That's okay? So we need to remember those small things, right? Commutative, you should remember that. Associative, you should remember that. Closure. Right. So closure is what you say. If we have A and B, let's say A and B belong to integer. Let's say A star B is A plus B. You have to make sure when you work out A plus B, it also is an integer. Right? So whatever the function is. Right? We should know a distributive one thing. Anybody remember the identity for wait, I'll skip a step. Yeah. Anybody remember the identity element? What's the identity element? You will always get back what?
What?
You'll always get back the original value, right? So A star E will always give you back E. Questions. You gotta remember this. The identity for addition is 0. Right? The identity for addition is 0. Identity for multiplication is 1. All right. Inverse always gives you back the what? Identity. Okay. The inverse for addition is what? Yeah. What is the inverse for addition? Minus A, right? What's the inverse of multiplication? 1 on A. That's okay. And then we have the different types of proofs. Exhaustive. Most important is the proof by induction, right? All right, so let's try a few of these now. Let's go. Try that there. Anybody missing the calculator? Sure. Yeah. Are you done? A and B, hurry up. Is that So part A is simple, right? This part B is not very well. Right, we're leaving on this slightly, the ones that easy we're leaving out, right?
No, it's not wrong without. Why did they all? It is not. Let's go. Same thing on the.
What was it? Proved by what? Or part two? Was he visible by him? This? Most likely. It's a crash here, Alright, let's now look back where it is. Right, let's see how this went now. Right, so, oh wait, I don't remember, they're now showing. What was the first part again? I don't have it there. What you had to do? Converse, and converse is what? What's the next one?
Show that something the very index.
So show that the concept positive,
Is equal to.
so that's negation of Q equal to the
I always see contribution of yes.
contrapositive of the inverse. Oh, okay. Of the same statement of generally.
That's it.
Right, so what's the inverse? Negation of P, negation of Q, right? So what's the contrapositive of this?
Q.
What's the contrapositive of this?
Negation of Q implies. Negation of Q implies.
So it will be negation, well, double negation of Q implies the double negation of P. Right, remember the one, the contrapositive of this, right? So you flip it around and negate. And now you'll end up with Q implies P, which is the conjugate. That was the first one, right? And the second was this. Well, I get to part one. Yeah, no? So they want us to find. So let's start with this, right? What would f of k be? F of k is what? 2 to the k plus 6 to the k. Right? And what would f to the k plus 1 be? 2 to the k plus 1 plus 6 to the k plus 1. That's okay? So you want to find a way to write it like this. Right? Bear in mind, right? You should have an idea what is this, right? 6 f to the k is this. Right? You want to show this equal to this. I'm giving you a little 2 minutes again. And then try the PMI. PMI is, I'm not too sure if it's the same thing, but I think the PMI is to prove that this is divisible by it. Yeah? Oh, you have to part one pass. Well, again, yes, part one.
Yes,
PMI as well.
That's like
PMI usual thing, so it holds n equals to 1. Assume true for n equals to k, and then prove that this is divisible by it. The objective is to prove that this is divisible by it. Sorry. This is divisible by it. So I can do this now. Now you know that. Right? That's your part one. Now, what way I have here? What way I want to get? So the first thing is you gotta get rid of this one, plus 1, right? So what do we do? Plus means what? multiply. So you should have something like this, right? 2 to the k by, well, I'm putting it 2 in front. And here is what? 6 to the 1 by 6 to the k. What's the difference? You have to do multiply this line, multiply this out, and you'll get the answer. Think about it. You want to go from here to here. You have to introduce something. Think about, just multiply this out. And it'll give you a nice little hint of what to do. But yeah. So if you multiply this, right? If you multiply this again, 6, 2 to the k plus 6, 6 to the k minus 4, 2 to the k. 6 minus 4 is how much? 2n. So instead of writing 2, all we have to write is 6, 2 to the k minus 4, 2 to the k. This is the same thing, right? And now we can just switch it around. 6, 2 to the k, 6, 2 to the k plus 6, 6 to the k minus 4, 2 to the k. And I can factor out 6 here. Right? And the only way I could have figured this out is by working with the original thing. Now do the PMI. Let n equal to 1, show it holds. N equal to k, n equal to k plus 1. Right? Keshav, you'll come on the board and you'll do it. Oh yeah, try that first, Keshav. Why I write this?
Yeah.
Oh, because from here, remember I was expanding out the answer a little bit. So I recognize that 6, 2 to the k. Well, when you expand the c, you're getting this, right? And I saw that 6 minus 4 is 2. Which is originally what I had here. So I replace 6, 2 to the k with this. Alright, so 6 minus 4 is how much? So these two are the same thing. But the reason I chose 6 and 4 was because of what the answer was. So if the answer needed 8 and 6, yeah, and just replace it. Right? So if the answer needed 8 and 6, I would have done 8 minus 6. Right? But that was just because of the proof that I wanted to do.
So we think that is lovely. So it's an appearance to different afterwards.
Yeah, I know. Let's see. Oh yeah, try the PMI first and then let's switch. One, started now, right? Anybody get it? Anybody get it? The CMI? So let's start, right? So we know that F to the N is equal to F to the N is equal to 2 again 2 to the N plus 6 to the N. Right, so for N equal to 1, that's 2 to the 1 plus 6 to the 1, which is 8. Therefore, divisible by 8. And then assume true. Assume true for N equal to 8. Sorry, N equal to K. That means F to the K is equal to 2 to the K plus 6 to the K. Right? So we know F to the K is divisible, right? So if you want, you could also write, let's say it's divisible by AE. Where A is any constant, right? This is any constant. So we know that this is divisible. Everybody okay with that? Nice. So now we have to show it holds for N equals to K plus 1. So we have F to the K plus 1. And we proved this already. We proved what F to the K plus 1, right? Tell me again. 6 F to the K minus 4 2 to the power of K. Right? So we have to show that this is divisible by 8. Right? But think of this here, Chloe. Is this divisible by 8 already? Remember, we already showed F to the K is divisible by 8, right? So I can write this. I can say when F to the K is equal to 8A. So I have 6 by 8A. That's okay? Now the focus is here. How do I show that this is divisible by 8? Right, we have a little ratchet up thing here, right? So watch this here. 4 is what? 4 is 2 by 2, right? By 2 to the k plus 1. Okay? Actually, you don't have to write that step, but watch this here. We have so that'll be 2 by 2 to the k plus 1. This is 8 by 6a, right? Watch what we can do here, right? Up. No, that's switched around because I want to show you divisible by 8. Right? So I'm going to break up 2, right? 2 is 8 multiplied by quarter. Right? So can I break up 2 as 8 by 1/4 2 to the k plus 1 and then factor out 8? Right? If you want, you can further simplify this, huh? This will be 8 to the 6a. A quarter is 2 to the minus 2. So you'll get 8 by 6a minus 2 to the k minus 1. Right? But at the end, this is what we're interested in, being able to factor out 8.
2 from the 2 k plus.
Yeah, I simplify it. And then you can cancel it off. So as I was saying, we didn't even have to write it here. We could have factored out 8 from the beginning. Right? You know, do all that. Right? But the objective is once you reach here, you identify that this could also be divisible by 8. And I switch them around. Multiplication commutative. And I switch them around, right? Now I follow went on. Don't worry with all this. But that this is a past paper. Paper trade over here. Paper trade. I just give you all some little more, some slightly more challenging ones. You never know what could come. I'm just giving you one that's slightly more challenging. Where you go? Why you fall until here? What's f of k? F of k is what? F of k is it? Just put k here, right? But and we have to assume it's divisible by 8. So f of k is divisible by 8. So instead of writing 8, I write a by some constant e. Right? So f of k is 8e. But remember, a line in the part 1 prove this. Yeah, prove this, right? So that means f of k is this, which is 80. I'm plugging 80. And then I just magically turn 4 into 8 on 2. That's all. Right? You don't want to do all that.
Oh,
you don't want to do all that.
Okay.
Right here,
Where do you want to?
you can just convert to 8. Yeah, you can just convert to 8. So instead of writing 4, write 8 over 2. And then put the 2 inside and you'll get the same. I realize after when I was working on it.
So, then check you all go here and drop you one.
I got.
Yeah.
All right, let's go again. The next hard one. So if you watch this one here when you're all done, you'll remember how 1 on x looks. Yeah, alright. Right, let's go back to the summary. Right, something that they also like to ask is this, right? Right. So after we do polynomials and after we do steps PMI, something else that they like to ask is the main and factor. And I'm already doing that, right? Then we have our surds and our logs. We gotta remember how to convert logs and surds and same rules, right? Here I have all the rules for log, which are the same rules for log, right? Right here you have the graph. You all recognize these graphs? Is the graph for what? Is the exponential graph, right? This is not the long graph yet. This is the exponential graph. And then the log graph looks like this, a reflection of it. You were in the line y equals there. All right, so that is your log graph. Then in functions, we got to remember a few of the graphs. I'll come back to that because we might not have time for all of that. But anybody recognize this? We're going to use this now. Here we have the modulus. How do we obtain the modulus of a graph? Right? You reflect the part below the x-axis above. So here, anyway, here's the graph 1 on x. Here's the graph 1 on x squared. Right? Suppose I ask for the graph y is the modulus of 1 on x. How will this change? The part on the left will go up here. That's okay? So since you're like that, let's try this one. All right, kind of hard to do this thing here, but write it fast now because it keep on practice. All right, but keep cutting off. Right, we'll be doing the sketch on the same diagram. Sketch those two. Write the functions down quickly now because the iPad keep crashing. Another one. Oh yeah. Write the functions down, sketch them quick, and then let's do part 1 and 2. Right, Joseph? Right, so before you do the modulus, stay sharp. What's the first thing you should do before you do the modulus? What's the first thing you should do before you do the modulus part? Yeah. So what Kesham said to do is to sketch 1/x minus 2. Right? And then do the modulus, right? Yeah. And then do the modulus after. So sketch 1 on x minus 2. Minus 2 over 3. Right? How much? Right, so it's a shift to the right and then modulus. Hurry up. Right, so this is sort of what a paper treatise look like. Huh? Yes. This is sometimes was some paper, it's really come back if you do that. I'm sure because that one I saw on the data. Because between now and March, you will do paper food. I mean, like 3 pieces in some us. Right, so I just check in to see what you all have. Right, this here is the graph of 1 on x. When you shift the graph to the right 2, it will look like this. What's your asymptote? Nathan, what's the new asymptote? Huh? That's right, 2? X equals to 2. And what's the last step again then, Narayan? One more step. Huh? Say that again? I got lost there. Right, yes,
What else?
huh?
Can I get any?
You need a modulus to the last part is what? The last part is just the reflect the part below the x-axis above. All right? Right, but they also want what? Catch y is equal to x plus 2. It's supposed to be done on graph paper, but we don't have, right? Right, what does x plus 2 look like? Next to 9. What does x plus 2 look like? Right, anybody can help them? X plus 2 is a what? A straight line, right? So let's pretend it looks something like that, right? What's up? Wrong? Who's that one? Stefan, wrong? X plus 2 wrong? Right, so wrong. Oh. Right, so on the same diagram, sketch both of them, show clearly the coordinates of any points which cross the x-axis. Right? So here is 2. What's this point here, Olive? I know it's a little small. What's that point there? What will that be? Over when x is 0. When x is 0, the function is what? It won't be negative a half, it will be positive a half. Nice. Right? And does it cut the x-axis at any point? Maybe the line, right? But somewhere down the road, right? Maybe the line. Who confused?
Yes, it is. Yes. Yeah.
Right. The graph will look like this, right? We're shipping everything here. We're shifting everything to the right too, so the graph will look like this. And the graph will look like this. That's okay? Right. They want us to point out where it cuts the x-axis. So, and the y-axis. Right, Jordan? So we know for sure the x-axis is an asymptote for this one. Right? But it cuts the y-axis when x is 0. So I'll plug it in x is 0, and I'll get y is the modulus of 1 over this. So again, the modulus of 1 over minus a half, which is a half. So it means it cuts here at a half. You know that? You sure? And the last part is they want us to draw y is x plus 2. Right? So the y-intercept is here, 2. And when x is 0, y is 2. When y is 0, x is minus 2. So they want us to show that, right? So our graph looks like this. All right. So if I ask you to solve, Adam, right? If I ask you to solve those 2 equations simultaneously, what you will end up with? If you have to solve those equations simultaneously. Anybody can help them? Can I say right there? So if they ask you to solve simultaneously, all you have to do is read off the points where they intersect. That's okay? Right, try part 3 now. Try part 3. X plus 2 is less than. Sorry, part 2. Solve that modulus there. Yeah. Solve the modulus. Here's solve the modulus again. Last part. How do we show modulus again? How do we sorry? How do we solve something with modulus? We can square both sides, or you can do it with what? Right? You can do it with it being positive, and you can do it with it being negative. Right? When it's positive, we can cross multiply x plus 2 by x minus 2 is less than 1. Right? Remember, it's a quadratic, right? So we will get x squared plus, no, sorry. We will get x squared minus 4 is less than 1. We will get x squared minus 5 is less than 0. What is doing reach here? Is that inequality? Huh? Right. Get the critical values first. The critical values are plus 5 and minus 5. Right? So therefore, it might look something like that. Minus root 5 plus root 5. Less than 0 is inside here. All right? Do the same thing here. Do the same thing here, and let's see where they intersect. All right, finish. Get a roll call, yeah. And it's up. About I can remember and if you know we get to go down. What is all this? What is all this? I gonna say how much you all got here? You carry the minus here if you want. So what is solution set? All together, root 3 minus root 3. So what would the solution set be? Yes. I see the minus sign here. Huh? Which one? The minus on the outside, so when you want every term to take a minus. If both take minus, then that'll be plus. So when you one could take a minus. Alright? So the minus sign, one could take the minus. Or if you do like it here, bring the minus here. If you can squeeze in one more now. Are they good? Nah, cool. Yeah, so like, this is the only solution of that, because this inside it. Right? Yeah, inside the. To the side, yes. Yeah. Right, let's just try one alphabet and we done now. Let's just try one alphabet and we done. Right, during the holidays, we'll be doing tricks, right? Tricks and starting at geometry. Right? Module 2 is tricks, geometry and vectors. Try this last one now. I thought you want to pick a easy one.
Yeah. Yeah, but you're the problem.
Oh, yeah, last question, Keshav. Oh, yeah, we have now. Oh, yeah, one question. Oh, yeah, oh, yeah. What I get for 1 and alpha?